Hey everybody and welcome. My name is James Quick and I'm here to talk to you about something that's really exciting, which is to build applications that can be run on phones, tablets, laptops, desktops, Xbox, and more. And what I'm really talking about here is Windows 10. And I'm talking about the Universal Windows Platform, UWP for short, which provides you, the developer, the avenue to create one project, one solution, export one app package, and submit that app package to one dev store that lets your app be accessible to anyone and everyone running Windows 10 on any of those different kinds of devices. So, what I want to focus on this talk here about is adaptive UI for Windows 10 for UWP. Because adaptive UI becomes extremely important because you could be running the same application on a phone and then on a tablet, a consumer could, and you want them to have a look and feel and an experience that's great on each one. And an adaptive UI is how you accomplish that. So previously in the past, you've been able to share code, you've been able to share logic, but now we're really getting into just one project and everything is there. So our UI and our layouts have to be designed to go across all these different devices. So here's what we're going to do. We're going to talk about a few different things, and we'll start with UWP Design Principles. Then we'll talk about what kind of devices and categories of devices you, the developer, would be developing for, things that run Windows 10. The next step will be to talk about some of the design techniques for building an adaptive UI. And then lastly, we'll talk about some of the new features in XAML and Visual Studio to help you build that adaptive UI. So we're not going to get hands-on yet. We're staying pretty theoretical here, but really want you to understand the importance of an adaptive UI with a UWP application because of the multitude of different devices that it can run across. So let's go ahead and start off by taking a few seconds to talk about UWP Design Principles. So the first thing I want to mention here is the idea that we at Microsoft want to be a little less prescriptive about how you design your layouts with Windows 10 with UWP. Now in the past, if you were to create a new project for Windows 8.1, you might have seen a couple of different templates that had predefined applications and you can kind of fill in and customize a little bit. Now if you create a UWP application, you just see one, the blank template. And that's because we want you to feel comfortable using your designs, your fonts, your icons, your layouts, etc. in ways that fit your application. So if you're stuck or need inspiration, we have some guidelines that you can look at. You can look at the Windows 10 built-in applications, but we really want you, again, to feel comfortable designing things that makes the most sense for you and your application. So that's first and foremost, just wanted to mention that. The second piece here is just kind of a concept, an idea. And it's the idea that with a phone, I view things pretty close to my face because it's a small device. With a tablet or a phablet even, or even a small laptop, things get pushed back a little further. And then with a desktop and a big monitor and all that kind of stuff, it gets back even further. So the overall idea is, even in addition to the different screen sizes that I have, another thing that comes along with that is different viewing distances. So two kind of tricky things there are screen sizes and then viewing distances. So one of the things that we've added here that really helps mitigate those kind of difficulties for you as a developer is the effective pixel. Now the effective pixel is an abstract unit, logical sizing unit that consists of X number of physical pixels. And again, it takes into account the pixel density of a device and allows the developer to really ignore screen resolution, screen density, not really have to take into account these viewing distances because the effective pixel takes care of that for us. One thing that goes along with this is the idea that 4 is the magic number. And this comes from the fact that you can scale down applications, right? Make it bigger or smaller. And as you do that, these applications are scaling by multiples of 4. So our recommendation for you is to use the number 4, use multiples of 4 for your width and your height and all that kind of stuff so that as things scale, it scales as smoothly as possible. So those are a couple of the just design principles here. Again, you can ignore scale, resolution, DPI, design and effective pixels, use the number 4, and build some great adaptive UIs. All right, so let's talk about again, the different devices that we would be developing for with Windows 10. And there's a lot of them. So the way I break this down typically is I try to keep it very simple. I think about a small, medium, large scenario where a small is a phone, a medium is a tablet, maybe a phablet, maybe a small laptop, and then a large is a regular size or big laptop, desktop, kind of bigger, right? So if we think about those three different categories, let's think about different snap points of where different views fit in. So obviously a phone is going to have a different orientation typically. It's going to be more vertical versus a tablet or a laptop. So these different kind of snap points or categories of devices, small, medium, large, phone, tablet, desktop, however you feel comfortable thinking about it, we have some suggested kind of snap points to keep in mind. So for phone, there's a 320 effective pixel snap point for a width. There's a 540. And then for phablets and tablets, there's a 740. And then desktop is 1024 and above. So that's how we break that down as a suggestion in terms of numbers. So one of my suggestions here, and after doing a demo on adaptive UI, I realized I was kind of overthinking things at times. So keep one thing very simple in your mind, that a phone, the smallest potential state that you have, is going to be more of a vertical orientation where you're used to scrolling through a list of things up and down. A tablet desktop, you might have some of that, but you have more width typically on the horizontal side, so you might kind of go side to side in a landscape position. So keep those couple of things. It seems very simple, and it should be. So keep those things in mind. And I want to take a second just to talk about a couple of the built-in applications for Windows 10. Things like the calculator, the mail client, the calendar client. And just to kind of reinforce to you that these are the same applications running on your laptop with Windows 10 that run on your mobile device running Windows 10, your cell phone. And to do that, obviously things have to kind of look and feel, right, appropriate on each one. So one of the things that the calculator app does is when you have enough screen real estate, it shows you a history of the different things that you have done. So if you type in 1 plus 1 equals 2 and then 2 plus 2 equals 4, it'll show you those previous things that you calculated. When you shrink down and you don't really have enough space, that disappears, right? On a phone scenario, you have less space, so you might not need to see those things. So keep those in mind. And so just as a reflection, as you design, know that you're adapting to size change, you're adapting to input change. And then also know that just to use the effective pixel. Again, it takes care of some of that headache for you. It makes it really easy to create things that look and feel great at different distances with different screen densities and all that kind of stuff. So next up, let's take a look at design techniques for adaptive UI. All right, so talking about design techniques for adaptive UI, really focus on what we call the 6 R's, what I call the 6 R's. It might just be me. And the 6 R's consist of 6 different techniques that all start with R, as you might expect. So the first one is reposition. Now things might just need to be repositioned from to the right of something to the bottom of something, or repositioned somewhere else on the screen. The second one is resize, and this happens, as you kind of shrink down. You think about a responsive UI, something that's very common term in web development, for instance. You want things to look and feel great on a mobile device because so many people are accessing the browser through their mobile device. And resize kind of naturally happens, especially if you're using stars in your grids and stuff like that. That says basically take the available width and divide it accordingly. Next piece is reflow. And reflow, and these will all kind of overlap with each other, but reflow, if you kind of think about, having things stacked out horizontally, a horizontal stack, for instance, on a laptop and tablet, when you go to a phone, you might want that to be more vertical, because again, you're used to doing that vertical orientation and vertical scrolling. So that's kind of a reflow there. Reveal, hide and reveal becomes very powerful, because on a phone scenario, you might hide some things that on a laptop or desktop, you have the space there, so why not use it and display something extra for the user? And this comes back to the calculator example, where the calculator, takes away some of the information that it shows you on a phone just because of limited space. Now another piece here is replace, and this is can be the similar idea of hide and reveal. So not only do you hide one and show another, you could also replace something with something else. And this could be, one of the examples I use is a predefined kind of layout or item template. and I have an item template defined for phone, tablet, and desktop, and I can switch between those as I go through the different states. And that's replace. Replace with a different structure, a different piece of content, a different something. And then re-architect is where we really get into a scenario where you design a UI specifically for each different of those small, medium, large, or however you break it down. So re-architect is, for an example, having a different XAML page for each one of those scenarios and then changing to them accordingly. So the 6 R's, not 10, 6 R's: reposition, resize, reflow, reveal, replace, and re-architect. Keep those in mind as you design. Try to keep those really simple examples, top of mind, and use them as you're kind of thinking about how to design. All right, now let's take a second and talk about how to build an adaptive UI. And what we're really going to focus on is some of the new XAML features, some of the new Visual Studio features that help us to build these adaptive UIs. And the first one is called visual states. In visual states, you can kind of think about the different states that we talked about earlier: the small, medium, large, phone, tablet, desktop, however you want to think about it. Think of those as different states, or remember we mentioned the snap points earlier, different states of your application. And so a visual state allows you to basically define a minimum width or height and say, phone state is from 0 effective pixels to 320, and medium is 320 to 720, and 720 plus is large, or whatever it is. So with these visual states, where you define the size for the different states, 3 different categories or more, you also get the adaptive triggers. Now the adaptive triggers you set within those different states to be able to change properties of these XAML controls that you have defined. So if I have a text object and I'm in a small state, I could set font size to 24, medium would be 32, and large would be 46, or whatever I want to do. Right? So I can go in and change any of those properties. I could change to a different predefined item template, which is kind of that replace scenario that we talked about earlier, in the adaptive trigger. So any of those XAML controls, properties of those XAML controls, you can change dynamically, all in XAML, without having to use C#, not having to use the code behind. And it provides a zero code solution, which is amazing. Again, in the past, you would have to manually detect all these things in your C# in your code behind and make the changes. With these adaptive triggers, you're going to use setters to set the properties of your XAML. So you choose your XAML controls. So you choose a target, which is the target property of a XAML control, and then you use that to change the property, and that's going to be the value that you change it to. So you'll always have your target and your value. One other piece of really useful XAML control here for adaptive UIs is the relative panel. And the relative panel is pretty simple. It allows you to set one thing relative to the location of another one. So if I have one thing dead center, I always want this one to be the right of it. As I move this one around, this one moves with it. Or if I want to go from right to below when I'm going from tablet or desktop to phone state, relative panel becomes very, very powerful. You can set things relative to the parent or relative to another control. And then the last piece is the split view. And this is probably more commonly known to you as the hamburger button menu. This has become a very popular one. But it's interesting to note that the split view by itself is a very bare bones kind of setup for creating your own hamburger menu or something similar. So it's the pane on the left or right that opens and closes and reveals different buttons and text that tells you what the buttons do. And then usually with a hamburger button menu, you have that hamburger button that you click to toggle the menu in and out. So the split view is very simple. It's got a pane where you kind of define the options that are in there, the buttons, and then it's got the content, and the content is going to be your regular page. And then you can change the content based on the buttons in the pane and all that kind of stuff. So again, the new features in XAML that become really cool and interesting with adaptive UIs here, the relative panel and the split view are two new controls. And then just features in XAML are the the visual states, the adaptive triggers, and then using the setter with property target and value to set properties of different XAML controls. Alright, so I just want to leave you guys with a few resources here. Hope that you take some time to play around with the Windows 10 Universal Windows Platform, specifically focusing here on adaptive UI, and build some really cool applications that scale and look great across all the different devices that run Windows 10. So thanks for watching, and we'll see you in the future.